Well, hello everyone. Thanks for joining our webinar. I think it's time to start. My name is Maria and I'm hosting this webinar. So I would like to give some introduction words. Firstly, this session is being recorded and you will get the recording as well as slide deck tomorrow latest. Also, please feel free to submit your questions to the question box during the presentation, and we'll have around 15 minutes for Q&A section at the end of the webinar. So now I'm glad to turn the floor over to Johan.
Yeah. So this is a talk about creating devices with multiple UI processes, why you might want to do that, and how to do it using Qt. So first, why you might want to do it. So single process applications may not be ideal for your use case. Splitting it up can help you increase stability. That is, if your UI is in multiple processes, one of them can crash or freeze, and it will still not bring down your whole UI. You can keep the state in the rest of the UI, restart that part, etc. It can also help you take advantage of multiple cores, and it will help with interoperability with other technologies. You can have, for instance, if you have some part of your application using another toolkit, you can still use it, or it's useful if you have some really good software already that you still want to use, as long as it supports the technology we use for multiprocesses, which is Wayland. And splitting it up can also mean that you can integrate third-party applications into your UI. So, yeah. So in order to support multiple processes, we use Wayland, which is a lightweight display server protocol. It's frequently referred to as a replacement for the X-Window system X-Window system. And it's a much smaller protocol. It's very small. It doesn't. So the X-Window system is what is used on desktop Linux, and it was designed a long time ago. You might have heard all of this already. Just think it's good to repeat. So with Wayland, most of that's removed, and it's only the things you really need. And it's designed for today's graphics hardware. That's the most important thing. So it's much more efficient than X. And Qt applications can already run on Wayland as clients by appending dash platform Wayland. So as long as you have a compositor running, the Qt applications will start them. You can also use the environment variable Qt _platform_Wayland Qt _platform okay, sorry. Qt _QPA _platform equals Wayland. That will also make Qt application starts as Wayland clients. So the server on Wayland is often referred to as a compositor. And so while we support running Qt applications as clients, we also support writing. We have an API for writing compositors. it's a very convenient API to make them yourself. And the key advantages of our API is if you want to animate client surfaces, such as moving them, rotating them, fading them, apply effects. And if you want to rapidly prototype different UI concepts, or divide the space between applications more dynamically. And also things like creating UI for switching between applications and showing previews and such. In this slide, you can see a sort of a cluster application. There's a part in the middle which shows a client, and there's a part of the top which shows like a status area, which is drawn by the compositor. So that's an example of things you might want to draw with your compositor. And there's also launchers and other stuff at the bottom. And we also have great support for extending the Wayland protocol with your own protocols. So you get a lot of help generating the right classes, and yeah, you might want to do that if you feel like there's something missing from the Wayland protocol. For instance, you might want to have your clients be able to show notifications. So that's an example of something you might want to write an extension for. Or it could be other things, like maybe the compositor should be able to tell the clients that they should switch between the light and the dark theme to sort of if you have like a night mode and a day mode, or then you might want to communicate that somehow to your clients, and that's where protocol extensions come in. So the Qt Wayland Compositor API makes this simple and fun. At least that's what I think. So the API was rewritten in Qt 5.7. If you tried the API in 5.6 or earlier, it's completely different now. And this version is officially supported since Qt 5.8. It consists of a high-level QML API where you can write compositors using only a few lines of QML. You still also have a C++ API available if you need to dig into the low-level stuff or make something crazy, then you can do that. Like I said, there's also support for writing extensions. And we support multiple screens, and we support the XDG shell v5 and IVI shell extensions. I'll get back to that later. So without further ado, here's a minimal compositor. This is a complete compositor in QML. It's sort of a desktop-like compositor. It shows windows, you can drag them around, maximize them, etc. So there's really a lot of stuff is done for you in this case and in many other cases. So there's really 4 key components in this small application. And that's the Wayland compositor, the WaylandOutput, the ShellSurface item, and WL shell. I'll go through each of these components and explain what they are and what you use them for. There's the Wayland compositor, which is it represents the compositor and is usually the root object of your application. And it needs to have Wayland output and a shell extension to be useful. So without these, it's still a compositor, but it won't do anything useful. So clients can connect, but they won't be able to show their content. So the output is very short. It's a screen. It has one required property, and that's the window property. And this is the window that represents the screen. So window in QML is on desktop. It's a window, but on embedded, window is sort of a screen, or the window is shown on one screen. So this is the content of your screen, basically. So this is sort of the simplest case where you have only one screen. There are 3 examples in the Qt Wayland repository that shows different configurations. It's the multi-screen example, spanning screens, and multi-output. I'll show screenshots from these later, so you can sort of get a feel for what's there and what you can look at for examples. There's also the ShellSurfaceltem. This is a standard desktop-like implementation for shell surfaces. So a shell surface is something the client creates and it communicates. It's a window in the client's, from the client's kind of view. It's a window, and this ShellSurfaceltem is an implementation on the compositor side to show the window, to handle stuff like requests for maximization, full screen, resizing, moving. And it inherits from QtQuick item, which means it behaves like a regular QML item. You can anchor it, you can transform it, you can animate it, and it needs to handle the on-surface destroyed signal. So this is what happens when the client decides that the shell surface should be destroyed. Then you need to actually destroy the shell surface item itself, or you can animate it and then destroy it. That's why it's explicit. If you need more control, you can also use the Qt Wayland Quick item instead, and then create all the handlers yourself. So with ShellSurfaceltem, you get the implementation for maximization, etc. With Qt Wayland Quick item, you can do it yourself or don't do it, which is useful if you want to create something like a preview of an application, or like a launcher, or some other part where you just want to show the content of the shell surface without actually making it interactive. Or maybe you think you have a better idea for how the window should behave. And last, we need the shell extension. In this case, it's the WL shell, and the shell extension describes it's a protocol. It's a protocol extension to Wayland. So there, you can either use WL shell, which was made first, or XTG shell version 5, or some other shell extension, and they describe how surfaces should be shown and managed. If so, for instance, on XTG shell and WL shell, there is stuff like maximization, moving, setting full screen, setting the window title. These are part of the shell extension. So if you switch out the shell extension, you can make something else. And for instance, there is a shell extension called IVI application, which is really simple, and that one almost only has the ability where the compositor can tell the client what size it should be. That's almost the only thing that's there. So it doesn't have a concept of wide window titles, etc. So enough about that. shell extension has one really important signal that you need to handle, and that's when the client asks to, or the client has created a shell surface. So what we usually want to do is append the shell surface to a list of shell surfaces, and then use that list to instantiate the shell surface item, which I explained on the previous slide. So here we see, I'm back on the previous slide. You can see there's a repeater which uses the shell surfaces list, and it creates one shell surface item for each shell surface. Yeah, so here's the minimal compositor running. It shows windows, you can drag them around. Yeah, this is just a screenshot, so I can't actually show you how it works because the webinar software isn't really made for live presentations or for animations. So I can't actually show you anything real. But here's the screenshot. You can drag the windows around, you can resize them, etc. It's just a boring desktop application or desktop compositor, really. Is this code running? Yeah. So I'll show you a couple of other examples. Like I said, there's a couple of multi-screen examples in the repository. So this is the spanning screens example. It has two screens, you can see both of them here, and it just maximizes a single window across two screens, and lets you interact with it, basically. So here it's showing a browser on the web page, and as you can see, it can sort of continues on the next screen. So this compositor is around 90 lines of QML. Could be shorter, but it supports multiple shell extensions, which makes it a bit longer. And there's a multi-screen example, which is also a desktop-like compositor. It has three screens in this instance. As you can see, one of the applications span multiple screens. You can move windows from one screen to the next. And this one is about 150 lines of code. So what happens here is instead of just having one Wayland output, you have three, and one window for each, and on each window there's one shell surface item for each application. So in this case, it's three shell surface items for a single window, one on each screen, and it's just offset. Yeah, so look at the repository for more details. And here is an overview compositor. Again, I'm just showing this to sort of give an idea of things you can do, or maybe you'll get some ideas for what you can do with this. This is a single window compositor. I've just shown 3 frames because I can actually show the animation here. The compositor shows an overview of all the running applications. So in this case, there's 8 applications running, and they're all as big as the screen. But they're scaled down to this overview, and when you click one of the clients, it will maximize, and you can start to interact with it. And if you click the toggle overview button, we'll go back to the overview again in a smooth, nice animation. Yeah, and the button here is also rendered by the compositor, so that's also really simple, just to add some simple UI to the compositor. And this is about 90 lines of code. So here's the last example. I showed this in a tutorial earlier. There's a link at the bottom. There you can actually see how I coded this and watch how it works with animation in real time. So this compositor has each application running in its own tab. So there's four applications, and you can, if you swipe on the middle, you can switch between applications. They will pan out, so you can see both clients when you swipe. And if you click the tabs at the bottom, they will animate it switching between back and forth. When you click the X, you will close the client. It will curl itself into a ball and roll off the screen. So this is sort of a silly thing. It's just to show you that these kinds of animations are easy to do with our API. Yeah, and there's also a live preview of each application, a thumbnail next to the title of the application. Yeah, so you can watch the tutorial for more information of how to create this kind of thing. So it's only 60 lines of code for the compositor, and there's 60 lines for the animation. So I think it's cool that it's possible to do this with so few lines of code, which is why I'm saying it all the time. Sorry if I sound like a broken record. Yeah, so that's it for the examples. There are other components of the API that I haven't talked about, and it's mostly because they're relevant for desktop and not device creation. There's stuff that's relevant when you have a mouse, and there's text input manager, which might actually be relevant because it's about virtual keyboards. So maybe have a look at that. And yeah, I've mentioned the IVI application, which is another shell extension, which is really simple and might be useful. Yeah. So the last part, I'll just explain about custom extensions, how you can create your own, or sort of give you an idea of how it works, or what you have to do. So first you need to define the protocol. You do that writing XML. You have interfaces with the events and requests. Then you use this XML file to generate a C++ interface. And on the client side, you then subclass a Qt Wayland client extension template and the generated class, and you implement you override functions to sort of say what happens when you get a certain event from the compositor. And there's also generated functions for sending requests. And on the server side, it's equally simple. It's just the opposite. You get handlers for requests, which you override, and you need to call functions to send events when you want to. And there's also QtQuick support for this using macro. And on each side, you just instantiate the object, and the extension automatically adds itself to the compositor. And for the compositor, it's telling the client that it's there and that it can be used. And on the client side, it automatically registers with the extension on the compositor side. So here's a very simple example of how a protocol can look like. So in this case, it's the example I mentioned earlier. Maybe you want your compositor to be able to tell your clients to switch between day and night mode. So you won't get a white glare in your eye if it's really dark. So in this case, it's only one interface, and it has one event, which is set night mode, and it can either be set to day or night. So that means on the compositor side, you would need to call the function generated for set night mode when you want to, and you also need to, of course, you need to instantiate the shell extension object. And in order to generate the class which you subclass, you need to add the config plus equals Wayland scanner to your project file, and also tell it where the XML file is. And it's almost exactly the same on the client side. I won't go through all this in detail. There's a really good example for this in the examples of the repository. It shows sort of similar stuff. It shows how the compositor can tell the clients to use larger or smaller font sizes, and the clients can request to be flipped or bounced around, and it shows quite a few things. So please look at that if you need more information about this. Yeah, that's it for the slides. If you have questions, there will be a question section now, but you can also talk to us later if you forget something. We are on Freenode at Qt-Lighthouse. And there's really mostly 4 of us that developed this. Qt Wayland, I'm Johan Helsing. Yeah. So I guess that's it. So we'll switch to the questions now. Thank you.
For now, sorry, yeah, thank you. And for now, I can see any questions in the question list. So if you have some, please be quick to submit them. Otherwise, we'll end the session, and then you'll be able to ask your questions directly by email, maybe. Okay, there are no questions in the box still. Seems like you were completely clear. Thank you all for joining, and you will receive the recording very soon, and have a nice evening.
Yeah. Thank you.
Okay, bye.